Okay, this is section 6.5, properties of logarithmic functions. Okay, so first we're just going to list some basic properties of logarithms. So for one, log base A of A. So when the base of the log and the argument are the same, this is equal to, and we can think about that. If I have x equals log base A of A, then I would say a to the x is equal to a, so what must x be? 1. So when the base and the argument are the same, it's equal to 1. If I have log base A of 1, and again, we can think about that one too. X is equal to log base A of 1. If I change that to an exponential expression, what must x be? Well, anything to what power would be 1? X would have to be 0. So log of any base of 1 is equal to 0. Alright, number 3. Log base A of A to the r power is equal to r. So when the base and the argument are the same, and the argument is raised to a power, then log base A of a to the r is equal to r. Now, similarly, if I have log base A of m to the r, this is equal to, that r exponent will come down as a coefficient. So this is the same as r times log base A of m. So, for example, if I had log base 2 of 5 to the third power, that's the same as 3 times log base 2 of 5. And I think that rule makes this rule, number 3, make a little bit more sense too. Since we know log base A of A is 1, when you bring that r down as a coefficient, you would just have r times 1, which is r. Alright, so 5 and 6. Number 5 says log base A of m times n can be broken down as a sum. So log base A of m plus log base A of n. So when you have two things being multiplied here in the argument, you could separate that into two logs being added together. And if the argument is a quotient, I can rewrite this with subtraction. Alright, so let's put this all together. Alright, you'll be asked to expand the following using log properties. So we'll look at a couple different examples. And the MyLabs Plus for this section asks you to do quite a few of these. So let's look at the examples on our sheet. So number 1, we have log base 3 of 5x. So I'm supposed to expand this. So since I have a product here, I can rewrite this as log base 3 of 5 plus log base 3 of x. Okay, number 2. And I think with these, I would pause it and try it, and then you can see if you got it right. Log base 3 of 3x squared. Okay, again, I have a product here, so I can separate these with addition. Log base 3 of 3 plus log base 3 of x squared. Now you should always simplify too. So here you should notice that the base and the argument are the same. So I know that this is going to be 1. And this exponent will come down as a coefficient. based on one of the above properties as well. So this is the same as 2 times log base 3 of x. Okay, number 3, we have log base a of the square root of x squared plus 1. Okay, so now let's think about the properties that we have and how this might expand. Remember, I can rewrite any radical as a rational exponent. So this is the same as log base a of x squared plus 1 to the 1/2 power, and then I can take that 1/2 down as a coefficient. Okay? All right. Why don't you try number 4, and we can take a look at that one in class. All right, another way you'll be asked to do this is you'll be asked to write the expression as a single log. So you're more or less being asked to go the other way. I'm going to give you something expanded, and now you need to combine it back into a single logarithm. So, for example, you could be given, let's say, 4 times log base 5 of x plus 5 minus log base 5 of x minus 4 minus log base 5 of x minus 14. Alright, so first thing you need to do is, since I do have a coefficient and I'm going the other way, I'm going to take that back up and make it an exponent. So this is log base 5 of x plus 5 to the 4th power. And now these two logarithms are being subtracted from this one. So I will divide. So this will be divided by x minus 4. And then we still have minus log base 5 of x minus 14. So finally, I'll have log base 5 of x plus 5 to the 4th I get about 1.942 if I round. Or, again, you could have used common log, just log, meaning base 10, 71.3 over log of the base, which was 9. And again, when you plug that into your calculator, you get the same value. So change of base formula is just a way to get a value for a log with a known base and argument using your calculator.
Okay, so let's try a couple of U-tries. So here's the first one. I want you to write this expression is the sum or difference of logs, and then try this one, writing it as a single log expression. So why don't you pause, try these, and then unpause it to see how you did. Okay, so let's go ahead and write this first one as a single log. Or, I'm sorry, is the sum or difference. So we'll stretch this one out. Okay, so we have one quotient here, so the first thing I'm going to do is split it. So I would say, okay, this is the natural log of the top, which is x to the 12th times the square root of 5 minus x minus the natural log of, let me give us a little more room, the denominator, so that's x minus 7 to the 10th. Okay, so now I still have a product here, so I can separate that with addition of two logs. So this would be the natural log of x to the 12th plus the natural log of the square root of 5 minus x, and then I still have that minus the natural log of x minus 7 to the 10th. Okay, so now remember, exponents can come down as coefficients, and remember this square root right here is an exponent. What is that? This actually means that this is the same as this expression to the 1/2, right? So as a final step, I can write 12 times the natural log of x plus 1/2 times the natural log of 5 minus x minus 10 times the natural log of x minus 7. So that looks good. So now let's try number 2. So we're going to write this as is one quotient, so as a single log. So remember, that means that I'll only write log once. So let's rewrite the problem. We have 3 log base 7 of x plus 8 minus log base 7 of x minus 19 minus log base 7 of x minus 11. Okay, so what do we have here? Since we have two subtractions, okay, right? So I have this minus and this minus. Both this log and this log are being subtracted from the first one, which means that these two expressions will be in the denominator. Alright, before we get to that, let's go ahead and take the 3 up as an exponent. So this is log base 7 of x plus 8 cubed, right? So remember, I only write log once, so these two expressions are going to be denominators. So this will be x minus 19 times x minus 11 in the denominator. So that's writing that one as a single log. Alright, take a look at the MyLabs Plus, come in with questions, and we'll definitely spend some more time on this in class.